Hello and welcome to my first ever C++ video log. Today I will be creating a logging framework. The goal is to provide a logger that can be used in a way similar to how you'd use a C++ output stream, such as logger, log message severity, and message. So that's the goal. So first off, we will define our log message severity. Enum class. There will be 5 severities, starting with the low severity of debug, then info, then warning, then critical, and then fatal. Why am I making these all one? That was a bit silly. That should be 2, that should be 3, that should be 4. And I'm using spaces, not tabs, because tabs are evil. Right. So our severity defined. Now the logger will be accessible through an abstract interface. The D from the solid OO principles means dependency inversion, and it's based around the idea that you depend on abstractions, not concretions, and in C++ an abstraction is basically a abstract base class, or effectively an interface. And I prefix all my interfaces with a lowercase I underscore, so my logger will be the abstraction of our logger object. So first thing we should always do when creating an abstract or a non-abstract base class that has virtual functions is to have a virtual destructor. This will avoid undefined behavior if you delete the object via its base class pointer. So that's our virtual destructor defined. Now we need to be able to set the severity filter of the logger object. So severity, I prefix all my arguments with a lowercase I, so you can tell at a glance that it is an argument. Similarly, I use a lowercase I for member variables. I is short for instance variables. This naming scheme originated from the now defunct operating system Symbian, but I quite like it and I've kept using it ever since. That's great. So I'll show on to getter as well. So there's a getter and a setter for the log severity. Now we want to be able to actually insert messages into the logger. To do that, we will need to first be able to insert the actual severity of the particular log message. So to do that, we will want an insertion operator defined for the severity. Next we want to be able to actually insert a message. So we could do this. Everyone should be using east const these days, not west const. So east const a message. Now there's a slight problem here. We are using interfaces, so we are not depending on concrete classes. Now standard string is a concrete class, part of the STL, but if we wanted to use this across a plugin or DLL boundary, or we wanted to not depend on a particular build setting or version of the STL, then ideally we want to be able to send an abstract string such as that. And I have actually defined an abstract string as part of my neolib utility library. So if we have a look in core iostream, it provides a minimum subset of useful string operations via an abstract interface, and we can convert from an iostream to a standard string or a standard string view. If we have a look at string, which derives from iostream via a reference counted intermediate class, which I won't go into the details of here, but iostream is a base of string, and in here we override the virtual iostream methods, and it contains a standard string object, and these virtual in the interface methods will defer their operations to the concrete standard string, which is not directly exposed over the interface. So this is similar in principle to how Microsoft COM works. Everything is done via interfaces, which is basically, as I say, is an abstract base class with virtual functions, but no member variables. That's the basic difference between an interface and ordinary classes, that there are no member variables. However, we do want to be able to easily log an ordinary standard string. So to do that, we can define a non-virtual helper method. So this non-virtual helper method will call the virtual method. We are including string, so that will call that as string is derived from iostream. So a standard string will not be passed directly over the interface, so we can share this interface between different DLLs or shared objects or plugins, and not be concerned with build settings or alignment layout of the concrete class standard string in this case. Right, what we need to do now is to be able to also do a flush or a standard end L like we would with C++ iostreams. So we need to define a end L struct and a flush struct, and have some convenience objects. Right, so now instead of doing standard endl or standard flush, we can do, in this case, neolib logger endl or neolib logger flush. If you want to shorten things, we could do a namespace neolog equals neolib then we could do neolog neolog, let's just make this so that we can access endl like that. That's the goal. Anyway, so we want to support So we want to be able to insert an end L. We're going to take one of these. This should be virtual, it's not a helper method. So and the same for flush as well. So we can insert the severity, insert a message, insert end L, insert flush, and we can change the filter of the logger. Don't think we need anything else at this stage for the interface. So now let's look at the concrete class. So we'll be able to support different types of loggers. Loggers which can log to basic iostream, so we can have standard out, standard error, or just a file. Or we might also want to log to a GUI. So we are abstracting that away from the logger interface, so we don't care what kind of logger object is behind the interface as far as the rest of the application that uses the logger is concerned. We will be able to instantiate the logger object of the appropriate type in our application initialization stage. So let's create an iostream logger. So this will be a template. As a char type and a char traits type, which defaults to char traits char t, class basic iostream logger. So we need a constructor. Taking a basic iostream char t, traits, so lowercase I for member variables and a lowercase a for arguments, so you can easily differentiate between the two, which is nice for constructor, just like this. So we take a reference of the stream, right, now we need to implement the interface methods. Right, don't forget your override keywords. Right, there are going to be two severity member variables, one for the filter and one for the next message that's being inserted. So this is in the wrong namespace, isn't it? It's not currently deriving from iLogger either. Severity I filter severity and severity I message severity. So defaulting to let's make the default info. So filter severity. Message severity is set when we insert it into the pseudo stream. Right. Inserting the message into the stream we have a reference to. It's going to be stream to standard string view. The endl is going to be this, and the operator is going to be this. Right. This should be all we need for now. And now we need to do a check that the message we're inserting is of the correct, is not being filtered out, because it's not as severe as what the filter is set to. So if the message severity is larger than or equal to the filter severity, then do that. So if the message severity is debug, which is 0, and the filter severity is fatal, which is 4, 0 is not greater than or equal to 4, so we will get the message. That seems to be correct. Right, now we need to test this. I've got this logger unit test codes set up beforehand, so let's iostream logger. That's using neolog equals silly, wasn't it? What am I typing? What am I doing? Neolog. Right. Neolog iostream logger. Where is that? Right, what we're going to do is, as a convenience, we want to have that specialized for chars. So using right, is that right? file stream. We don't want a file stream, do we? We want an iostream. It's better. So, logger neolog severity info. This is a test of info severity message. Right, let's see if this works. See if it compiles first. Nope. Flush T. Ah. Let's try again. Got F stream down here as well, haven't we? We don't want a file stream, we just want an iostream. But that will allow us to use a file stream, because file stream will be derived from iostream, or we can, as we're using here, we're just using a standard stream. So compiled, see if it works. Yep. Okay. Let's test the severity is actually working properly by doing a debug. This shouldn't display because the default severity is info. So correct. So if we go logger set filter neolog severity debug two. Let's try that. Seems to work. Right. Now let's check that it works via the abstract interface rather than via the concrete iostream logger class. We can define a neolog I logger reference. Right, let's try it. Seems to work. Excellent. Right. That's the basics of a logging framework. Thank you. This will do for my first ever coding vlog. Bye bye.